In this Maths Olympiad question, we need to find the solutions to the equation 3 to the power of x plus 3 to the power of y plus 3 to the power of z is equal to 22,113, where x is smaller than y, which is smaller than z. So we've got our equation here. We're also told that x is smaller than y, which is smaller than z, and that x, y, and z are all in the natural numbers. So the first thing to notice is that on the left, we're adding together three multiples of 3, which as x, y, and z are whole numbers means that our right hand must be a multiple of 3 itself. So let's work out how many 3's go into that. So I'm going to use the bush shelter method here. So 3's into 2, they don't go. So let's go 3's into 22 is 7 with a remainder of 1. 3's into 11 is 3, remainder 2. 3's into 21 is 7 exactly, and then 3's into 3 give us 1. So we've just worked out that 22,113 is 3 lots of 7,371. But if we add together the digits, 7, 3, 7 and 1, we get 18 there, which is a multiple of 3. So we must be able to divide again. So let's use our bush shelter method. 3's into 7 is 2, remainder 1. 3's into 13 is 4, remainder 1. 3's into 17 is 5, remainder 2. And then the 3's into 21 is 7 exactly. So we've now got 3 times 2,457. 2,457 is also a multiple of 3. So let's do some more division. This one's a little bit quicker because we can see that 3's into 24 goes 8 times. 3's into 57 goes 19 times. But again, 819, well, we can see very quickly with this one, this must be a multiple of 9 because 81 is 9 times 90, and 9 is 9 times 1. So we can split that into 9 times 91, and 9 is 3 squared. So looking at that, we've got 3 to the power of 5. So we know that 3 to the x plus 3 to the y plus 3 to the z must equal 3 to the power of 5 times by 91. We're now going to try and factorise out this left-hand side by taking out the most powers of 3 that we can. Now, as x is the smallest of our 3 unknowns, then the largest multiple of 3 that we can get out of those 3 terms is 3 to the power of x. So we're going to factorise that out. So we take out the 3 to the x, and this leaves us with 1 plus 3 to the power of y minus x, because that's just 3 to the power of y divided by 3 to the power of x, plus 3 to the power of z minus x, and this is still equal to the 3 to the power of 5 times by 91 on the right-hand side. Now, equating these two, we can see that on the left-hand side, that bracket, that can't be a power of 3 because it's 2 powers of 3 added together plus an extra 1. So it's going to be 1 more than a power of 3, which means that that 3 to the x, they're all the 3's we can take out. So that must be equal to the 3 to the power of 5 from the right-hand side, which means our bracket must be equal to the 91. Now, if 3 to the power of x is equal to 3 to the power of 5, that means x must be equal to 5. And we can substitute that into our other equation. So we've got 1 plus 3 to the y minus 5 plus 3 to the power of z minus 5 is equal to 91. Well, taking 1 away from both sides, we get 3 to the power of y minus 5 plus 3 to the power of z minus 5 is equal to 90. And well, 90 is just 3 squared times 10. So we're going to repeat that trick by taking some 3's out again. So now as y is smaller than z, the largest power of 3 that we can take out of both of the terms on the left-hand side is 3 to the y minus 5. So we end up with that times by 1 plus our 3 to the z minus 5 minus that whole y minus 5. Well, that simplifies to 3 to the power of y minus 5 times 1 plus 3 to the z minus y. As before, as that's equal to 3 squared times 10, our 3 to the y minus 5 must be equal to the 3 squared, and our bracket must be equal to 10. So now we've got that y is equal to 7, and 1 plus 3 to the power of z minus 7 is equal to 10. Well, subtracting 1 from both sides, we get 3 to the z minus 7 is equal to 9. Well, 9 is equal to 3 squared, so if z minus 7 is equal to 2, then z must equal 9. And there we go, we've got our 3 solutions. X is equal to 5, y is equal to 7, and z is equal to 9. If you've enjoyed this video, don't forget to subscribe to the Doing Maths channel or check out some more of my videos by clicking on the links here.